Hi guys! Before we begin with the applications of trigonometry, I hope you have all gone through introduction to trigonometry, trigonometric ratios and identities of trigonometry. The link is given above and I would also mention the links in the description box. The entire chapter of applications of trigonometry is based on three simple concepts. We would first discuss these concepts and then see some usage with the help of some examples. These are not at all difficult, so pay good attention and you are all sorted. The first is line of sight. Line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The next is angle of elevation of the point viewed, which is the angle formed by the line of sight with the horizontal when the point being viewed is above the horizontal level. That is the case when we raise our head to look at the object. Simple, right? I told you. And you need not go into any depression to understand this last one, which is angle of depression. Angle of depression of a point on the object being viewed is the angle formed by the line of sight with the horizontal when the point is below the horizontal level. That is the case when we lower our head to look at the point being viewed. And this is it. We now know what is line of sight, what is angle of elevation, and angle of depression. This means we are now ready to solve problems on the applications of trigonometry. So, shall we start? Okay, here we go. Example 1 is a tower stands vertically on the ground. From a point on the ground which is 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is found to be 60 degree. Here AB represents the tower and we need to find the height of the tower. CB is the distance of the point from the tower and angle ACB is the angle of elevation. We need to determine the height of the tower, that is AB. Also, ACB is a triangle, right angled at B. To solve the problem, we choose the trigonometric ratio tan 60 degree, or we can also choose cot 60 degree, but I am choosing tan 60 degree here because the ratio involves AB and BC both. Now tan 60 is AB upon BC, that is root 3 is equal to AB upon 15. That means AB is 15 root 3. So the height of the tower is 15 root 3 meters. Easy, right? Let's see one more. An electrician has to repair an electric fault on a pole of height 5 meters. She needs to reach a point 1.3 meter below the top of the pole to undertake the repair work, as shown here. What should be the length of the ladder that she should use, which, when inclined at an angle of 60 degree to the horizontal, would enable her to reach the required position? Also, how far from the foot of the pole should she place the foot of the ladder? Now, as we can see, the electrician is required to reach the point B on the pole AD. So, BD is equal to AD minus AB, which is 5 minus 1.3 meters, which is 3.7 meters. Here, BC represents the ladder. We need to find its length. That means the hypotenuse of the right triangle BDC. Now, since we know the perpendicular and we need to find the hypotenuse, can you think which trigonometric ratio should we consider? Well, of course, it should be sine 60 degree because sine 60 would be perpendicular upon hypotenuse. That is, sine 60 degree is equal to BD upon BC. Root 3 by 2 is sine 60, so it will be root 3 by 2 equal to 3.7 by BC. Now BC would be 3.7 into 2 by root 3. that is 4.28. That means the length of the ladder should be 4.28 meters. Moving on to the next part. We need to find out how far from the foot of the pole should she place the foot of the ladder. Here we can use tan or cos since we have the perpendicular, the hypotenuse and also the angle of elevation. Let's try with tan. Tan 60 degree is perpendicular upon base, hence it would be BD upon DC. That is root 3 is equal to 3.7 upon DC. So DC is equal to 3.7 upon root 3, which is 2.14. Therefore, she should place the foot of the ladder at a distance of 2.14 meter from the pole. Would you want to try the same using cos 60 degree? Please do. It would be fun. And don't forget to let us know what you got. And hey, give us a thumbs up too. Moving on to the next example. An observer 1.5 meter tall is 28.5 meter away from a chimney. The angle of elevation of the top of the chimney from her eyes is 45 degrees. What is the height of the chimney? Here AB is the chimney, CD the observer, and ADE the angle of elevation. In this case, ADE is a triangle right angled at E, and we are required to find the height of the chimney. We have AB equal to AE plus BE, which is equal to AE plus 1.5, and DE equal to CB, which is also equal to 28.5 meter. To determine AE, we choose a trigonometric ratio that involves both AE and DE. You guessed it right. We would choose the tangent of the angle of elevation. Tan 45 degree is equal to AE upon DE, or 1 is equal to AE upon 28.5 because tan 45 degree is 1. That means AB is equal to 28.5 plus 1.5, which is 30. Hence, the height of the chimney is 30 meters. Moving on to the next one. From a point P on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degrees. A flag is hoisted at the top of the building, and the angle of elevation of the top of the flagstaff from P is 45 degrees. Find the length of the flagstaff and the distance of the building from the point P. AB denotes the height of the building here, BD the flagstaff, and P the given point. Note that there are two right triangles, PAB and PAD. We are required to find the length of the flagstaff, that is DB, and the distance of the building from the point P, that is PA. Now, since we know that the height of the building AB, we will first consider the right triangle PAB. We have tan 30 degree equal to AB upon AB. AB upon AP. That is 1 by root 3 equal to 10 upon AP. AP is equal to 10 root 3. That is, the distance of the building from P is 10 root 3 meters, which is 17.32 meters. Next, let us suppose dB is equal to x meter. Then AD would be 10 plus x meters. Now in right triangle PAD, tan 45 degree would be AD upon AP. So 10 plus x upon 10 root 3. That means 10 plus x is equal to 10 root 3. And hence x is equal to 10 times root 3 minus 1, which is approximately equal to 7.32. So the length of the flagstaff is 7.32 meters. Next example. The shadow of a tower standing on the level ground is found to be 40-meter longer when the sun's altitude is 30 degree than when it is 60 degrees. We need to find the height of the tower. Here AB is the tower and BC is the length of the shadow when the sun's altitude is 60 degree. That is, the angle of elevation of the top of the tower from the tip of the shadow is 60 degree and dB is the length of the shadow when the angle of elevation is 30 degree. Now, let AB be h meters and dB is 40-meter longer than BC. So, dB is equal to 40 plus x meter. Now we have two right triangles, ABC and ABD. In triangle ABC, tan 60 degree is equal to root 3 equal to h upon x. Tan 60 is AB upon BC and hence root 3 is equal to h upon x. So h would be root 3x. Let's note it down for the moment. Now in triangle ABD, tan 30 degree is equal to AB upon BD. That means 1 by root 3 is equal to h upon x plus 40. Now from 1 we have h equal to root 3x. Let's substitute that and we get 1 by root 3 equal to root 3x upon x plus 40. That is x plus 40 equal to root 3 times root 3x. So 3x is equal to x plus 40 which gives us x equal to 20. So height is 20 root 3. Therefore, the height of the tower is 20 root 3 meters. Let's see the next example now. The angles of depression of the top and bottom of an 8-meter tall building from the top of a multi-storied building are 30 degree and 45 degree respectively. Find the height of the multi-storied building and the distance between the two buildings. Here PC denotes the multi-storied building and AB denotes the 8-meter tall building. We are interested to determine the height of the multi-storied building, that is PC, and the distance between the two buildings, that is AC. Now look at the figure carefully. Observe that PB is a transversal to the parallel lines PQ and BD. Therefore, angle QPB and angle PBD are alternate angles and so are equal. So, angle PBD is also 30 degrees. Similarly, angle PAC is equal to 45 degrees. In right triangle PBD, we have tan 30 degree equal to PD upon BD or 1 by root 3 equal to PD upon BD. So PD is equal to PD root 3. In right triangle PAC, we have tan 45 degree equal to PC upon AC. So we can say 1 is equal to PC upon AC or PC is equal to AC. Also, PC is equal to PD plus DC. Therefore, PD plus DC is equal to AC. Now, since AC is equal to BD and DC is equal to AB, which is also equal to 8 meters, we get PD plus 8 equal to BD, which is equal to, or simply PD plus 8 is equal to PD root 3. This gives PD equal to 8 upon root 3 minus 1. Upon solving, we get PD equal to 4 times root 3 plus 1. And how did we do that? Let us know in the comment section below. So, the height of the multi-storied building is 4 times root 3 plus 1 plus 8, which gives 4 times root 3 plus 3. And the distance between the two buildings is also 4 times root 3 plus 3 meters. Next question. From a point on the bridge across a river, the angles of depression of the banks on opposite sides of the river are 30° and 45° respectively. If the bridge is at a height of 3 meters from the banks, find the width of the river. Here A and B represent points on the bank on opposite sides of the river, so that AB is the width of the river. P is a point on the bridge at a height of 3 meters, that is, dP is equal to 3 meters. We are interested to determine the width of the river, which is the length of the side AB of the triangle APB. Now, AB is equal to AD plus DB. In right triangle APD, angle A is equal to 30 degrees. So, tan 30 degree is equal to PD upon AD. Or we can say 1 by root 3 is equal to 3 upon AD. That is, AD is equal to 3 root 3 meters. Also, in right triangle PBD, angle B is equal to 45 degree. So, tan 45 is equal to PD upon BD. We can say 1 is equal to PD upon BD. So PD is equal to BD, which is equal to 3 meters. Now AB is equal to BD plus AD, which is equal to 3 root 3 plus 3. Or we can say it is 3 times root 3 plus 1 meters. Therefore, the width of the river is 3 times root 3 plus 1 meters. That's it for the day. Subscribe now for more. And if you like the video, do give us a thumbs up, share with your friends, and keep watching ISA Kids. Check out our other grade 9 and grade 10 science videos also. Have a lovely day. Bye bye.